All right, so we have already done the circumference or fence of a circle, and now we are going to work on, you might have guessed, the area of a circle. I want you to notice I put a little 2 up here to remind you to note after your label, it's a square unit, okay? So today I am going to show you the formula. I know you've worked with it last year, but it's always hard, I think, for students to keep track of the 2 different formulas, the area of a circle and the circumference of a circle. So in this formula, you need to know area equals pi times r squared. I always remember pi r squared like that, all smushed together because we know that means that they're multiplied. But I had some students last year that always wrote it pi times r times r. See if you can think about why. A lot of times, you might have guessed, a lot of times people see this 2 and think that it is times 2. But remember, if this number is a 6, it is actually 6 times 6, which is 36. So they wrote it like this throughout the unit to keep that straight in their head. So if you want to try this, to plug this in, I'll go through the arithmetic below, but I want you to find the area if the radius is 3 meters, okay? So I've already kind of done this right here. I wrote it as 3.14 times 3 times 3, because remember, r squared is r times r. A lot of big mistakes are made when you put a 6 here. It is 3 times 3, which is 9. I did the arithmetic, 3.14 times 9, and I got 28.26 meters squared. If you need to put little stars, smiley faces, remember that the area is always a square unit. Recheck your tests and quizzes when you do that. So I want you to find the area if the radius is 4, and the second one is I want you to find the area if you know the diameter is 20. I'm going to move this. You can go ahead and pause me, but I'm going to work through these right now. So if you want to try it on your own, pause. So if I know that r is squared, then I know that r squared is going to be equal to 16. Okay, so I'm going to do 3.14 times 16. 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. And then I know it's all times 1, so it's going to be 4 times 1 is 4, 1, 3. It's got a little smaller than I would like. 8, because we got to kill a tree, remember. 8 plus 4 is 12. 8 plus 4 is 12, plus the 1 is 13. And 3 plus 1 is 5. We got to place that right there. So I have 53.24, and let's do centimeters. Centimeters squared. Let's do centimeters here too. Now we have the problem of a diameter. So if I know that the diameter is 20, I know that the radius is 10, because it's half of the diameter. So I know that radius squared equals 100. I like this one because I know that 3.14 times 100, I just need to swish this 2 to the right, so it's 314 centimeters squared. Move that over. Okay. Please make sure you know what you are looking at, because I've had students square this before, and then you're multiplying times 400, and you don't want to do that. So the other thing you are going to be asked to do is to do combined figures. So in this is like the shape of a basketball free throw, but our little model here has this diameter or side as 4 centimeters and this as 7 centimeters. If you want to try it on your own, go ahead, and then I'm going to show you the math off to the right. So what I have done here is the easy part where I simply did 7 times 4 is 28 centimeters squared. Notice I drew this to remind me. I could even put a 28 centimeters squared just to remind myself that that's that area. Now I need to find this area. So if I reason through it, I need to do the area of the whole circle, 3.14 times 2 times 2, so that's a radius squared, but I need to divide that whole thing in half because I'm only looking at half of that right over here. So I did that and I got 3.14 times 4 because r squared is 4, and I got 12.56. I divided it by 2 and I got 6.28. A lot of times this is where students stop, and you are correct to this point, but you need to finish it because now you know that this is 6.28 centimeters squared. We need to add these two up. So when we do that, look again, we are adding 2 decimal pieces together. We got 34.28 centimeters squared. If they ask you to round to the nearest whole unit, you would simply, there's your last digit of the whole number, you would say it would be about 34 centimeters squared if they ask you an approximate answer. So in the next one, we are going to work through a multi-step question. This is more like the problem solving you do when we do CML. So how many times greater is an 18-inch pizza than an 8-inch pizza? When they talk about how many inches your pizza is, they're actually talking about the diameter of the pizza. So if we have an 8-inch pizza, I already put out here that the radius is 4, so the radius squared equals 16. I have found finding the r squared off to the side is a really nice way of not messing that up in your equation or in your formula. So I already said, okay, if my diameter is 16, my radius is 8, so my r squared is 64. And these are all in inches, of course. Now I need to take 3.14 and I need to multiply it by 16. And over here, I need to take 3.14 and multiply it by 64. And so let's go ahead and do that arithmetic. So I'm getting closer here. Notice I'm trying not to talk while I do my math. As you know, that's when Mrs. McKinley makes the biggest mistakes. So this is the area of my first 8-inch pizza. I'm going to find the 16-inch pizza. Okay, so I have one pizza that is about 50 inches squared, and this is 200, almost 201 inches squared. So how many times bigger is this pizza than this pizza in terms of area? Well, if we say 200 is more compatible with the 50, notice I put approximately. It's approximately 4 times bigger than the 8-inch. So again, this one you might do all of your arithmetic correctly here, and you'll be able to look at the numbers, but you need to finish what the question is asking. All right, the last thing we are going to talk about here is making a circle graph. This is kind of fun when you realize that you have the skills to do this and actually figure out the degrees of each section. So if we're making a circle graph, the table below here represents what fraction of ski trails are beginner trails, intermediate trails, and advanced trails. I want you to make a circle graph to represent this data. At first, students look at this and go, what? Let's talk about what we know. You should know by now that a circle, an entire circle, has a measure of 360 degrees. So if we know that, we need to find out what 3/10 of 360 degrees is. And here, when we do this, we can kind of cross out the 0, and 3 times 36, just do that. That's 108, and that's degrees. So this should be 108 degrees on the circle graph. Half of 360, most of you know, just without even doing it, is 180 degrees. And then we do the 1/5, and that will be 72 if you divide that all out by 5. I'm not going to take the time to do that. Hopefully you can do that. 72 degrees. So then when we come down here to make our circle graph, it's nice that you know that one of them is 180 degrees. And that is the blue one. So if I go like this, you can use a protractor for the other measures, but I can do that, and then I'm just going to shade it a little bit in blue. That was the easy one. Okay, now I know that 72 is just a little bit below that 90 degree. So again, I could use a protractor from here to exactly measure it, but I'm just going to represent it as 72 degrees. And that one is the black. And now we're getting to the green, which is 108 degrees. And I'm going to shade that in green. So that's how you make an exact pie chart using the fractional data that you are given up here. You multiply it as a part of a whole 360 degrees, and there you go. Your assignment can get tricky with multi-step questions. Please look back and see what it is you're calculating before you finally answer the question. And that goes for the quizzes and tests too. It's easy to make an error simply because you haven't added the two numbers together. Everything else might be right. You may use your notes on the upcoming quiz, so that's really nice. But do commit all these formulas to memory. They're very important, and you won't escape doing them really for the rest of your math career. Have a great lesson.